All right, we have reached the Ask Us Anything panel, and that means anything. The first question I will ask is, where's Andre? Somebody afraid to get destroyed? All right, so basically the whole idea here is you, the audience, both in the room and online, and we have a bunch of questions from folks who've been watching virtually. We haven't had time to get to your questions. We'll get to them because they're definitely relevant to the people here. But let's, right off the bat, who wants to ask the first question? Anything you want to know? Right there? Can you get him a mic? Because nobody's running the middle? It's coming.
So there was some guidance yesterday on using ampersand as a return value, which is basically don't.
There he is.
Is there any guidance on using it as a parameter for functions?
I guess that was my guidance. So, do you have guidance? As a parameter, I actually have some bonus slides that Herb really wanted me to write, but I didn't have time to present them even at 30% light speed. There's a number of theories on how you should pass things. Certainly, if you just pass by const ref, you're always going to get C++ 03 style performance. Then there's the take by value and then move. And although that's just one overload, I'm not a big fan because it's a copy plus move or move plus move, and that can actually be twice as slow as C++ 03, and it's not optimal. So the usual pattern you should be following is either the move semantics pattern where you overload const tref and tref, and then you move from the tref, or the perfect forwarding pattern where you have a universal reference that's a template directly on that function, and then you say forward tt, possibly variadic for 0 more arguments. Other cases where you should use R-value references as parameters don't usually come up. Usually you want to either move or perfectly forward. The one case that I found, and it's the only case I've ever found where you actually want to form a const R-value reference, is to forbid your function from taking temporaries. There's a fair number of cases where you don't want a function to take a temporary because you're going to get pointers into its guts or something, and you can overload on const whatever ref, and then say equals delete or maybe static assert inside of it or something, and say, hey, don't call me temporaries.
My advice is a little bit simpler. Don't. Just use move constructors and move assignments. Unless you're whipped really hard to do anything more complicated, don't. Don't be too clever.
Yeah, I was going to say, I also am a fan of the pass by value and just have one overload, because otherwise it's a combinatoric problem with your number of arguments, especially when you get into sync arguments, which are very common in constructors. And if you have 3 or 4 arguments to a constructor that are sync arguments, and you're going to end up with all permutations of copy and move of all of those. So the additional cost, where he says it can be twice as slow, is usually for a very small or at least relatively fixed-sized object. So in reality, from what I've seen, the compiler usually gets rid of it anyways as part of the inlining pass, and the hit's pretty minor.
I think we should fix the compiler to not make it slower.
Good? Down there?
Yeah, I noticed that there was a that if you use the move, it was one of the slides today. If you are supposed to use a move, the take by value and then do a move, I assume that it's not going to take something that it's not supposed to take. In other words, that would be if you're passing in a const, a string, a literal string or something, but not if you're passing in something that might be used someplace. I mean, if they tell you to do that, what happens if the argument is not something that you want to steal things from?
Right. So because the argument's getting passed in by value, right, means that within that function, you have sole ownership of it. So it's okay for you to steal the guts. What you've done is you've lifted out the decision to copy or not copy into that argument to the caller. Okay? So So, and the compiler makes that decision based on whether or not it's handed an R value or an L value, right? So
Okay,
an L value
you
will
can't
get
mess
copied
yourself
in.
up is the point by doing that. You
Right,
won't,
you
won't
can't
get the
mess
wrong
yourself up.
results. Okay. Just wanted to check.
Questions?
So in the last, I guess it's on. In the last talk, there was a slide where like an old style loop with iterators is converted to something that had better performance. If you can do that correctly, why not make that into a optimization in the compiler itself?
It is a semantic change, right? If you are modifying the object inside the body of the loop, then you can't make that transformation. The compiler will, in many cases, maybe almost every case, figure this out and do the right thing. But it won't do it in every single case.
All right, thank you.
Also clarity. Remember, you write code for people and not just for compilers.
Yeah.
So you actually want the new version of the code. You'll be able to understand it better even if you wrote it yourself 2 seconds ago, the old way.
I think that example is an example of something very, very important. I've been going on about code rejuvenation for a few years and had no traction, so I was very happy to see this happening. This is the way we get rid of really ugly old code. We can rewrite it into something much nicer and more manageable. And this is just one example.
And I just patted Chandler on the back, thanking him for telling us about it, but acknowledging that you're representing the hard work done by many, many other people who are not in this room. So you thanked them, but thank you again. This is helping the entire C++ industry move forward.
So this is a question from online that actually came during Bjorna's talk, the wonderful keynote that we never got to. This person, Matt PD, how much of the work and research done in the Prolang community can be reapplied to concepts? In particular, I'm thinking of Haskell's type classes with combined with the powerful type inference. Is it possible to borrow, adapt some of that work?
I guess I should answer this. A lot of people who believed in the old concepts believed in them partly because they were very similar to Haskell type classes. I feel that the new system based on predicates are more flexible, simpler, and faster to compile. So one of the things we have learned is not to do an object-oriented style of checking for a generic system.
I have a couple of questions for Chandler. So you had your first slide where you forgot to, where you were trying to close something on a null pointer. You were calling close on a null pointer, and you detected that. I'm wondering how much the if statement before that had to do with it, and would you have been able to detect it even if you didn't have the if statement before that?
If we did not have the if statement before that, I think that the static analyzer assumes by the dereference that it cannot be null.
Okay.
But I really am not certain. Again, I was presenting a lot of work of other people. The static analyzer is probably the part of Clang I know the least about.
Okay.
It's a great question that you should send an email to the open source community to ask, though.
Okay, and the other question is again related to the for loop transformation that you did. The iterator that you used was not constant, right? I mean, in the original code, but you were still able to do it. But I can imagine containers that sort of change their state when you iterate over them. Would you be able to do the same transformation then as well?
In some cases, we'll do the transformation. You have to understand, this is not a sound transformation. We're not going to try to prove that it's safe or not safe. It's a heuristic transformation. So we look for indicators that this is a safe thing, that it is the typical pattern, and indicators that it isn't, and there's kind of a trade-off. And there's actually a threshold you can set in the tool. But it's a case-by-case basis and how it fits into the heuristics.
Okay, thanks.
Well, that's it. That's good. That's 2 questions. Go for it.
I just want to add, as an STL maintainer, it is insanely dangerous if you modify a container while iterating. Such code is awful and should be broken.
And you hear about it.
I have a question about integer types. I've seen lots of different integer types on the slides, from size t to unsigned long to int to whatever. Is there some guidance what to use, not to use? And there was also thrown into the C std int header with the with all the types in there.
So it is a fact of life that in a system, I'm not sure who asked, I can't see myself thinking here. Okay, thanks. It's a fact of life that in a systems level language, integers of different sizes are necessary. Unsigned integers are also necessary in different sizes. So it boils down to the fact that you're gonna have this whether you like it or not. Auto is at the same time a good helper and a bane for the integer, the zoo of integer types in C and C++. So there's no simple guidance that can be given. At systems in systems level work, we sort of essentially ban anything that's not fixed size. So we use int 32_t and int 64_t and etc. for most of our work. Auto does help with that, fortunately, but also auto is probably the most dangerous tool in combination with the many conversions and all of the arcane rules that govern conversions, some of which are actually non-portable, or port poorly, such as like unsigned converts to long if it fits. Otherwise, it doesn't. Otherwise it converts to unsigned long. This is a not very well-known rule. So anyhow, the short answer is there's no simple and easy guideline that I could give. I could say this is something we need to live with, and we derive great advantages from it, from the many integer types in C++. We derive great efficiency benefits, and it's something we need to live with.
So Andre, I'll give you a simple set of guidelines. All right, 1, use signed integers unless you need. 2's complement arithmetic or a bit pattern. All right. 2, if you're using an integer in a common, and I mean lots of instances, or large data structure, use the smallest integer that will suffice. Otherwise, use an int if you think that the big O of the number of things you have is kind of how many things you can count, like thousands and millions, maybe, then use an int. If the big O of the number of things you have is something that you wouldn't want to go around counting, use a 64-bit integer. And stop worrying and use tools to catch it when you get it wrong.
Yeah, I was going to say something very similar. Use ints until you have a reason not to. Don't use unsigned unless you are fiddling with bit patterns, and never mix signed and unsigned.
So we have another one from online that just came in, so it's fresh. This is from N. Zubaki. Python has pip or PIP, whatever. I don't know Python crap. Ruby has gem. Node.js has npm. C++ has ... Nothing standard, Herb.
Right. So you might have noticed I had a slide where wouldn't it be great if we had a PyPy plus apt-get for C++? And I said, watch this space. I hope to have more news for you in a year or two.
That's the answer? Great.
Oh. And in the meantime, I also mentioned we have things that are nascent and platform-specific, like Mac ports, and like NuGet for C++. So come back tomorrow, and there's a part on NuGet for C++.
Garrett Surek's talk.
That'll be a good one.
Please.
I'm not sure, but I think he was referring to PIP, Python
Yes.
Improvement Process proposal.
So basically he continues. He says library deployment and dependency management should not be as hard as it is today in C++. Right. There needs to be something standard, blah, 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 blah. And you sort of answered that.
Yes, he meant
Right.
PyPy.
Okay. On the standardizations, on the sort of adding features kind of side, we have these now notorious n followed by number, which are like out in the open. You can reach them from isocpp.org or from the community mailing list, which is there's a community website that lists all the.
If you can type WG21 into your browser, you'll find all the papers, more than you ever wanted to know about standard C++.
So questions? Ask anything. Great. Over here.
So first question is about the library. do you plan to have something standard for parsing command line options?
Is that to me?
And the second one is about compatibility. It seems that there are many features which kind of fights old issues which we inherit from C. Like there is an advice, don't use bare pointers. Don't you think it would be nice to have another standard which would basically not allow you to compile the dangerous code?
So for your first question, command line options, that was one of the libraries that I mentioned, including preferences as that we could work on that we haven't done anything with yet. We'd love to see your proposal. And what was your second question?
Second question? Yeah, the second one about compatibility.
It's a big advantage of C++, and we are gradually, for instance, with smart pointers, like you say, we're adding safe tools, but staying backward compatible with a great backward compatibility story so that people can then migrate to the new replacements while not breaking existing code. And there are tools that coming, and not just from one place, that help you to use the new features.
Yeah, that's right. But like the issue is new users, they basically can easily get lost when they have too many tools.
But I really hope that no new user reads the standard.
And new users should be reading effective C++ 14.
Okay.
Wait, that's out now?
Does anybody else?
It will be.
Oh yes, and Bjarne has that new nice book, Tour of C++, coming later this month. Thank you.
Okay. I just want to make one. Can I make a comment about the question? This is going to sound really rich coming from me because I'm not on the standardization committee and I never have been on the standardization committee. But I think it's really important for people to recognize that a tremendous amount of work goes into anything that ends up in the standard. And I only know indirectly because I read the proposals and I talk to people and stuff like that. So for anybody who's here or who's watching who thinks it'd be really nice to have some kind of a library or some new language feature, but especially a library, if you feel passionately about that and you really want to see that happen, you need to get involved either directly or indirectly to get some momentum going. I'm sure other people in the committee here will have more to say about that, but I think it's important to recognize that wanting something is not going to make it happen. It takes people and a huge amount of time, but the payoff is that you can make a contribution to the community that will be around for everybody else. So if you think you have a good idea and you'd like to see it pursued, you need to go from being pursued to pursuing it yourself.
And let me answer two questions that people just came up with, actually several after my talk this morning. The most gratifying thing afterwards was walking through and seeing how many people had Cinder and other websites open on their computers. But the other thing was people coming up and asking, how can I participate? This is great to hear. The answer is go to isocpp.org, click standardization or go to /std, and you will find meetings and participation, how to participate, how to join the email reflectors, how to join in the study groups, how to submit a library proposal, how to submit a language proposal. Okay. You'll find it all there.
Okay, go to isocpp.org. Next.
Okay, as you probably know, very many projects and companies use only a very limited subset of C++. Don't you think that this is a sign that language you're writing books about and language that people actually use are two different languages?
There are a huge variety of ways people are using the language. There are people who really get nervous if you use any feature that Dennis Ritchie added after the original version. And then there's people that are sort of stuck in the 80s, and there's people who don't have any choice to be stuck in the 80s. And then there's people who are actually today shipping products using C++ 14 features. This is a real soup, but I have hope. And the newer features are easier to use and tend to give better performance. So there's hope.
So one thing I wanted to add is that I don't have any problems with that different people use different parts of C++. I especially abhor the idea that people start wanting to subsection C++ the way some committees have done. And that direction generally leads to huge amounts of fragmentation. things that are optional, things that you may or may not need to support. I always find that just abhorrent. And you know what? C++ is big enough that it can afford many different uses, many different kinds of programming model. And I think that's particularly what makes it healthy.
Yeah, I agree with this, and I think there's really not a good common subset, right? If you went out there and you looked from company to company and industry to industry, they end up establishing their different guidelines. Unfortunately, I think many of those guidelines are horribly misguided. Some of them are pretty good. Some are horribly misguided. I myself tend to write in a subset of C++, and it's somewhat documented. If you get Alex Stepanov's book, Elements of Programming, Bjarne and I wrote an appendix for it for the language, the subset of C++ used in the book. And that's pretty much, almost all of my code falls into that subset, and it's 7 pages. But it's a different subset than pretty much anybody else on the planet writes in, so.
Does somebody, okay.
I found there are many drawbacks with the IO stream. It has virtual function call overhead, it has locale overhead, and it's the most complex library in the standard library. Is there any consensus to find the replacement of it?
I actually asked that on the library reflector. I was grumbling that there's a lot of interest in allocators, which are, okay, and not so much interest in fixing or somehow superseding IO streams, which I hate in all its forms. And I don't say there was a lot of interest in it. Yes. I certainly would love to see a proposal that or even just a library, not even a proposal, a library that strictly superseded IO streams, meaning that it has type safety like IO streams does, and it's extensible in some sort of convenient format, which half applies to IO streams, but it's efficient, unlike IO streams, and it doesn't mix code and data. So sort of on the boost format side of the spectrum, but modern. So not using boost formats, clever at the time, but now clunky, operator modulo chaining. I mean, that was cool, like back in 03. But now we have like variadic templates, so we should use that. We should just have like print, string, comma, arg, 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 and then we're just done. And maybe we overload some print method or something. But I certainly don't have such a library waiting in the wings. And I haven't seen anybody else. I mean, boost format.
Have you seen this week's mailing?
Oh, is there something cool in this mailing? I have not read it yet.
There is a proposal.
Oh, awesome.
Actually, and it came through the STUD proposals, open community forum by a non-previous standards committee member who's going to show up in Chicago, I believe, in 2.5 weeks, because I talked to him.
Cool.
And very briefly, there's 2 parts. I think Bjarne wants your mic also. But there's 2 issues. Somebody else was mentioning this before. To me, as far as I understand it, there's IO streams issue and the IO manip issue, which is even bigger. The IO streams issue is they're big, fat, slow. A lot of that's locales. Then there's the IO manip, which is just unusable with all the shift and set precision and blah, blah, blah. This proposal addresses the IO manip issue, which will make IO streams much more usable. You can decide whether this is a good thing, but it will solve the, I think, bigger usability problem. But then there's still the performance problem, but hopefully we can solve that separately and still use this on top of whatever replaces.
I actually like IO streams. This may not be such a surprise, since I did invent streams in the first place, but they have grown a lot of barnacles over the years. Locales is one thing, and nobody ever worked on proper formatting for floating point numbers, which is what you're referring to. And so, yes, I would like to see something better and nicer than IO streams. But let's not forget what you also mentioned. It is type safe and it is extensible. And it's type sensitive, so that you don't have to repeat all of these formatting rules that can be a source of errors. So yes, find something better and faster, but don't break the really fundamental contribution of IO streams, which is type safe, type sensitive, and extensible.
Excellent.
I want to add one thing quickly. If there's anyone out there getting ideas, I have a couple of points. One, please separate formatting from I/O. There are a lot of use cases for I/O that don't need formatting, and there are a lot of use cases for formatting that don't need I/O. Locale, it's the same thing. And please avoid using long chains of binary operators, not because they're a bad idea, they're actually a really nice and convenient syntax. Unfortunately, they necessitate a terribly slow compiler implementation, and we have no good ideas of how to speed it up. Variadic templates are significantly more efficient to compile.
This question is for Chandler. Your description of memory sanitizer reminded me of some work which was done a few years ago at Microsoft Research in Cambridge, UK. This is the byte granularity isolation work that basically does the same thing. It associates metadata with each byte of user memory and does different kinds of checks for legality of writes or control flow transfers. Is your work, is the memory sanitizer based on it, or is it like based on some other work done at some other by some other researchers, or is this something new?
There are a bunch of questions there. First off, it's not my work. Remember, I'm presenting other people's work. There's a person in the Moscow office of Google, Kostya, who leads a team that's built all of these sanitizers, and he deserves all the credit. They've worked with Valgrind very extensively, and also with the pin debugger and Dr. Memory. All of these are kind of related dynamic analysis, but binary instrumentation tools. I believe that they were familiar with some compiler instrumentation-based tools, and also tools that use shadow memory. Valgrind itself uses something analogous to shadow memory. I don't know if any of these tools are directly based on any of the existing tools. I don't believe that they are. But I don't think that there's anything particularly novel about the approach. I think the interesting thing is the productionization and the fact that these tools, I mean, memory sanitizer being the least productionized, but these tools are actually built for widespread use and deployment, and they're very deeply integrated into a workflow, and that's actually the killer feature.
I have a question about the behavior you call universal references. I find it kind of confusing that if I have a function that takes some type by ref, that I can't bind L values when I call that. But if I throw a template around it, all of a sudden L values bind to that. So what exactly is going on here?
The committee didn't want to use triple ampersand.
I mean, is the question about the syntax, or the reuse of ampersand, or why it happens one way in a function and a different way in a template?
It's the difference between the two. It's like the syntax type ref to me says R value reference, and then in some context L values can bind to it, templates, and in other contexts it can't. And the difference there I find surprising.
Historically, there was work on R value references, which was trying to solve historically, there were two problems that the committee wanted to solve. One of them was perfect forwarding, and then separately, they were trying to solve move semantics. And it turned out that at some point, somebody came up with the idea of using ampersand to mean a new kind of reference for representing R value references. And then at some point, those two groups recognized that they were, in some sense, solving problems that could be meshed in some way. And then there was a question about what do you do about the syntax for one of these references that will solve perfect forwarding. And ultimately, they said that's what I call a universal reference. And at some point in some of the proposals I read in the past, they actually had 3 ampersands. There actually was 2 different syntactic notions. And then they decided, well, we don't want to change the syntax of the language too much. We don't want to add another token. And so somehow they decided, oh, well, we'll solve the problem by using a single notion and combining it with reference collapsing. And there are people who know more about this than I do, who are firmly convinced that explaining a single syntax for R value references combined with the rules for reference collapsing is no more difficult to understand than the idea that I put forward, which is to call them something different. So I don't know if that helps with your question or not, but fundamentally it was an arbitrary decision that was made to use the same syntax, which means different things depending on the context.
So I may be one of these people. So I actually think that this is a simple but surprising feature. The fundamental difference between when you don't use a template and you do is that the template can deduce a reference type. Once the T takes on a reference type, you have an R value reference to an L value reference, and reference collapsing takes place. And that's nothing new or surprising. You've been able to bind a template T to a reference type forever. There's nothing new here, right? Having the two ampersands doesn't change the fact that T is bound to a reference. This is the same pattern you see with type defs hiding part of a compound type.
I have a slightly different reading of history and a conclusion that comes from it. I think we see a major case of mission creep here. We had two problems. One, that we wanted move constructors, basically, and the second, somebody wanted perfect forwarding. And then people figured out, well, we can just generalize this and we can have a R-value reference and we can devise rules for it so that it can do the two things we want and lots more things we haven't thought about. And till I see more than I've seen now, I'll say just stay away from it. Use move constructors, move assignments, and use perfect forwarding. And apart from that, be very, very careful.
So something I always I rant about when I've reviewed Scott's slides and others. It's not reference collapsing. It's not something that's always happened actually. If you have say a template on type name T and you take T-ref, so an old style C++03 L-value reference, T, using template argument deduction, will never be deduced to be a reference. It just never happens. If you look at the rules, it always wants to deduce a plain type. In some sense, that's what the language is designed to do. And then when R-value references and perfect forwarding and move semantics were voted in, the committee actually tweaked the rule. I call it a tweak. Tweaked the rules for template argument deduction and said in this one situation where you've got T-ref-ref and T is a template parameter on the function, and the argument is an L value, then instead of the actual type X, we're going to say XRef. Then reference collapsing happens, but that's a totally later step. And it is weird and special that this tweak is so specific to it being a template parameter and being specific to T-ref-ref. And it did save us from having to type T-ref-ref-ref. Sometimes I wish that had been it, just so that we didn't have to explain this all the time. But fundamentally, aside from the whole tweak thing, imagine you're in C++03 land and you write a template and you say, okay, I'm template type name T-ref, and then lowercase t, and then you're like, okay, this thing is modifiable. I'm going to modify it, and then you call it with like a const int x, and now your T has been deduced to be const int, and what looked like it was modifiable is actually const. The constness has slipped in through template argument deduction. In the case of R-value references, the L value-ness is now, through a novel tweak, slipping in through the template parameter. So it is new, but it's also kind of old style. And it's complicated, but I don't view it as like a critical flaw or anything. It's certainly mind-bending the first time you learn it.
So I think STL here just made Bjarne's point. So I agree with Bjarne on this one, that I actually think R-value references are unfortunate. They're overly complex for what they do. But I think fortunately you don't have to use them that much. Like Bjarne said, you need a move constructor. Unfortunately right now you need move assignment, and that's because of a language defect, which hopefully will be fixed in C++14. For everything else, all your other sync arguments, you pass by value. And in the rare cases where you do need forwarding, then you use them for a template for forwarding, which means they don't appear many places in your code, and you don't worry about it.
And one big thing, just about move in general, a lot of people think move means writing ampersand everywhere, just like people used to think that exception safety meant writing try-catch everywhere. Tain't so. You don't even need to write, and that's your point, you don't need to write the characters ampersand yourself by hand unless you're writing a move constructor or assignment operator, or you want to perfectly forward an argument. Otherwise, just don't worry about it. And it means this here and this here.
Two additional comments. Just one of them is the rules for template argument deduction that Stefan talked about. They apply to auto as well, because so pretty much anything that's true of templates is true for auto as well. And the second thing is that if you would like to see what life would have looked like had they decided to go T-ref-ref-ref, just make some mistakes and compile with GCC, because some of its error messages actually produce that as part of the type.
Just want to go on record, Charles. I take the fifth on that one.
Okay, this is a bit more general and somewhat out of curiosity. There's a lot of features in C++ and programming in general, and I know I myself have been taught by a very certain individual that you can do things with templates that I did not think were possible. Has there ever been anything that you've seen or come across that somebody's kind of used these features that you've created and you go, wow, you know, I never really thought you could have done that? And likewise, has anyone ever completely misused it in such a way that you wanted to beat them with a possibly heavy stick?
Yes, and often in both cases. And by the way, the surprising uses is very much by design. I've always had this fear of designing a system that could only do what I could imagine. And I've been trying very hard not to do that.
So Andre, his question was also, you've never been stumped by someone else's insane, variadic.
I took the fifth one, so probably.
Take the sixth.
The short answer is, so you know, there's this, I think, misplaced qualification of some people toward me, which is Andre, the template guy, and what I've always tried to do was meaningful designs, and the fact that I'm not above using a macro if that helps my design. It does happen, although not too often, hopefully. So I've always tried to create meaningful designs, and if templates were a good tool for that, I would use them. So I would not be the person who would use templates, without meaning. I do believe that there is some pendulum that has swung a bit too widely in some direction. So I agree with Bjarne that I did feel that there's some exaggeration of use of some mechanism, in spite of it not being very effective in some cases. So what I think should be done, go forth, do good designs, and if templates help, use them. If they don't use them. Use whatever you have at hand, and this is the goal should be creating beautiful designs. I also agree with Bjarne. Sorry for agreeing so much with you. I also agree with Bjarne on this thing. Like it's a great tool. A great tool has always found users beyond its. It has had a life of its own. This is also a definition happening with art. Like, a work of art is always kind of having its own life beyond what the author intended it to be. And I think even with great engineering enterprises, creations, this is also the case very often. So a great tool is going to always find use that this creator is going to not have expected. And, let's give it to the man. Bjarne did succeed in creating such a tool.
Yes, agreed.
So I really wanted to jump in here because I've only really become a language designer in the last 10 years, and I've had the benefit of sitting with the guys on the stage. And one thing I've learned about this whole game of language design is, and unfortunately I can't really say specifically more than what I'm going to say, and that is pretty much to constrain things but not constrain things so much that it prevents all the possibilities out there. And I think that's one of the reasons why that templates, I mean, it was a seminal day when I read Andre's book that, wow, my God, these things are more than just containers. I don't really know if that idea of doing static compilations and all that, I didn't think it was designed into templates right at the beginning. I never really knew that. Maybe this is the time I can ask Bjarne.
I put in numbers, values as template arguments so that we could use them over the dead bodies of many type theorists that said this was not a good thing. I think there's a general comment that's worth making, that every new and powerful feature will be seriously overused for a while.
Yeah.
It takes some time before the community learns what actually works, and what actually works tend to require a bit of restraint from users. And for the first while, people go hog wild and build things that can't be maintained. This has happened with virtual functions. This has happened with class hierarchies. It's happened with overloaded operators. It's happened with exceptions too, yes, as people want to use them not for error handling. What a horrible, horrible idea. And it's been done with templates, and it's going to happen with a lot of the C++ 11 and C++ 14 features. Yeah. It's just in the nature. Some people really, really want to try something new, just like some people are overly conservative.
So we created, or you've actually helped us create this tool in front of you known as C++ 11.14. And part of the invention is one of you may discover some unintended usage in there. I have my own suspicions of what some of those are, which I won't reveal. But I've observed time and time again this design where the constraint, how much constraint to put on a feature is really the key to enabling possibilities. And I've observed that in concepts, okay, which you're going to see. I've observed that in some of the other features that people have put forward, and I'm hoping that this is going to guide us to move forward in the same way.
Okay, we got a question here.
I'd like to continue the topic of integers. When reading C++ 11 standard, I noticed like uint32, uint64, and I thought, oh, finally we have like specific bitness something, but then I didn't find anything in the standard saying that uint32 is guaranteed to be 32-bit. So
it is totally guaranteed to be 32 bits. It may not always be available, but if you read the C99 standard that C++ incorporates by reference, if a machine has 8, 16, 32, 64 bits, it must provide uint64t, blah. They must be exactly that width. It doesn't say exactly which type it is. And there's more wiggle wording for the uint least and then the uint fast. Those are at least or that size. They may be bigger, but the ones that don't have that, they are exactly that width if they exist. And of course, they exist in all the architectures we care about.
So although it says some unspecified type, it's
right.
still guaranteed to have this number of bits.
Right. The unspecified bit means that it could be unsigned int, it could be unsigned long, it could be unsigned char if your machine is particularly brutal. So it's not going to tell you exactly which type. And the usual place that matters is if you form a pointer to it, because then the type matters. But if you only care about the width, then you don't actually care about the underlying type.
Yeah. Thank you.
Or template specialization, said Andre. Yes, you would care in that case.
And second question to Bjarne, could you elaborate on not using unsigned ints, unsigned types, unless you want to do bit arithmetic? Because it means I would need to revise my code review policy.
Whenever you mix signed and unsigned numbers, you get trouble. The rules are just very surprising, and they turn up in code in the strangest places. They correlate very strongly with bugs. Now, when people use unsigned numbers, they usually have a reason, and the reason will be something like, well, it can't be negative, or I need an extra bit. If you need an extra bit, I am very reluctant to believe you that you really need it, and I don't think that's a good reason. When you think you can't have negative numbers, you will have somebody who initialized your unsigned with -2 and think they get -2, and things like that. It is just highly error prone. I think one of the sad things about the standard library is that the indices are unsigned, whereas array indices are signed, and you're sort of doomed to have confusion and problems with that. There are far too many integer types, there are far too lenient rules for mixing them together, and it's a major bug source, which is why I'm saying stay as simple as you can, use integers till you really, really need something else.
Use int unless you need something different. Then still use something signed until you really need something different. Then resort to unsigned. And yes, it's unfortunately a mistake in the STL in the standard library that we use unsigned indices. If you are writing a very large data structure, the only case where you would really care about the unsigned is if you know it's an array of characters that's going to be bigger than half of memory. I don't know of any other case where it matters, and that is only on a 32-bit system or less, and it just does not come up in practice very much.
I'd like to add one other thing. Think about this. How frequently have you written arithmetic and wanted mod 2 behavior? All right? It will take you a long time to remember the last time you wanted 2 to the 32 modular behavior. That's really unusual. Why would you select a type which gives you that and prevents any tool from ever finding a bug because it thinks you need mod 2 behavior?
Just wanted to add.
You need a mic.
Yeah. Well, I was going to ask a question, but now actually I want to argue with your answer. More specifically, and if you could just, I don't know. No, I'll go with the first one. So, when defining a class, you have to repeat the name of the class many times. You have
and
to
the
write
compiler does it for you even more times.
True, but probably unimportant. Repetition is, of course, evil when we make the programmer do it. Granted, the redundancy can be expressive, but there are limits as to the redundancy that's worthwhile. And I'm wondering whether the sense of the group is that, for example, the fact that an assignment operator has to fit a certain boilerplate pattern every time, a copy constructor, same pattern every time, a move constructor, same pattern every time, a destructor has to repeat the name of the class. Why? Why not just call it destroy? It seems like that's an opportunity for increased brevity without loss of expressiveness.
I tried repeatedly to find a shorthand for introducing the usual operations and was beaten to bloody pulp each time because people found the notation obscure and unusual. If you have something and you dare try propose something.
I'll just comment too that historically, every once in a while somebody pops up with they overload certain kinds of operators in ways you would not expect, which have weird parameter types or weird return types or whatever, usually for making very specific domain-specific languages, and it looks completely crazy at first until you find out that in their particular area it actually has some meaning. So I'm not necessarily saying that this would justify this kind of flexibility in declaring these kinds of signatures. I will point out that people have used it to what I consider to be reasonable effect from time to time. So it has an upside as well.
I'll point out one thing. The briefest way to specify these is to not. They will be generated in most cases.
Also, Bill Plowger Dinkenware has a convention that I haven't seen other people using very often. When he opens a class, vector, list, or whatever, the first thing he does is say type def, whatever type I am, so like vector underscore my type. He has to use the underscore because we're in the STL. But after that, he can always just use the my type def to refer to the class itself. And if you hate repeating a different class name, no, it's not completely pointless. Oh, he's got his hand up? No, you're just snickering?
I think I made a comment without using words.
It does allow you to scan a class definition and see what it's doing without constantly remembering what the name of the class is. I don't know whether I would pick it up into my own style, but that's certainly a style that exists. I don't think many people have thought is possible. Now, you can't use it all the time because the standard really wants the names of like constructors to actually use the class name and not a type def. I don't actually know why. There's some questions I just don't want to ask of the core language.
Hi, I have two questions. One is for Andrei, but for the panel as well. Static if. So I was wondering, like, what does Andre thinks about the paper Static If considered? I think it was kind of rough in that it kind of focused on concepts and said that it would interfere with that. But in general, as a mechanism to extend the template system, it's kind of useful and general. Like
Can you raise your hand so I can see someone? Wanna? Okay, thank you. Continue.
Yeah, that's the first one, and the second one is.
Just ask one for now. How is he going to remember that?
Okay, that's the first one.
I take the fifth.
Taking the fifth,
Wisdom.
Not going to answer it.
Okay.
I'll take the fifth too.
Okay, so ask the second one.
I'm co-author of that paper, so obviously I agree with it. There may be uses of a static if that are not damaging to our definition of interfaces and for the compilation based on trees. But the proposal, as it were, commingled three separate issues under a single syntax, and I think it would have been very damaging, and the reason is in that paper.
Oh, so the second question is going to be fast. I was wondering, is there any research about computing times at compile time? Because templates are mostly they're kind of limited for computing times, and you can do, because they're kind of restrictive on how you compute times and how you pass them around. But like, is there any research going on or any work about like computing times, types at compile time, and then, yeah.
Are you asking research on doing more work at compile time, doing computation at compile time?
Not computation, computing type specifically.
Oh,
so this is a
types.
type system question. Yeah.
Do you mean like reflection, like computing
Yes.
types derived from other types?
Yes, but at compile time.
There's a study group, in fact.
Nice.
And Chandler is the chair of it.
So to elaborate a little bit more, there's a study group we've talked. We're specifically trying to get papers for static reflection, essentially, right? Building up types at compile time. There are some of the very early building blocks as papers. There was one in Bristol, and I think there will be another one in Chicago, although I haven't checked the mailing yet. And I think the real thing that's holding reflection back at the moment is getting C++ 14 out the door. And I'm shockingly okay with that. That's certainly what's holding it back on my end, and I think on a lot of other people's end, that we do have a finite amount of resources, and it's important to keep track of reflection, but it's not the most pressing thing. The most pressing thing for some of us is getting C++ 14 out the door.
I would like to ask a question, maybe of more general kind to all members of the panel. So before C++ 11, we had a wonderful set of materials, including great series, effective C++, engineering puzzles, which resulted in more than maybe 200 topics which delve into details of the language so that you master them, you gain confidence, you can do good code, you can do good code reviews. Now we are talking about C++ 14, and this niche is still not filled. So the question is, what would be your pragmatic advice on how to master new elements in the language so that it can be quickly be used in production without learning the standard?
I'll observe that the C++ programming language, the book, has advice sections in every chapter.
So can we get one from the internet now? So this is from Fred Overflow. He's asked quite a few questions. Bjarne, I would imagine it's going to start with you, but in your talk, you said, if you understand int and vector, you understand C++. The interface of vector has R-value references, push-back overload, universal references and variadic templates, and place-back template. Does this mean every C++ programmer needs to understand these new mechanisms? It seems they are not well understood, even among experts. How are we going to teach them to novices?
I think you can teach people vector quite easily. I teach most of it to freshmen. And I think the mistake people make is they look at some construct in the language and they want to understand every use and misuse of it. What I'm trying to teach and what I find reasonably easy to teach is fairly idiomatic uses of these things.
I was going to add to that and just say I think the point is if you understand how to use a vector and how to use int, not necessarily how to implement them.
Well, you have to understand the underlying implementation model, but then again, you don't have to understand all the details of the implementation.
Yes.
Scott, so yes, there's a human in here who wants to ask.
Human, get him.
You watch too many
All
zombie
I have
films.
here are names and words.
I am a
not
human.
humans.
All right. My question was about variadic templates and unpacking them. And I haven't seen in in the 14 or the 17 if there's a way to get what level of unpacking you're at. So say I passed in an array. There was 4 things in it and I wanted to unpack them all. Before I had to use some kind of template stuff where I had template specializations on a specific number, 1, 2, 3. Is there any way to find out how far into the unpacking you are with the variadic template?
Size of ...
Thank you.
There's actually in C++ 14, they just voted in the integer sequences, which actually every implementer has in their library because we need it desperately for things like tuplecat. And now that functionality has been exposed to users. And essentially, if you're given, say, a list of types, and you want to be able to index into them, like into a tuple, you can make an integer sequence, which is just like template int ... n, and then you'll get, foobar 0, 1, 2, and then you can use the cool feature of variadic templates where you expand 2 packs simultaneously, and you essentially match them up. So you can say t and then 0, and then the next type and then 1, and so forth. So that's how you can actually figure out where you are at any point in a single variadic blast. The alternative is recursion and using size of ... to figure out how many are remaining. Oftentimes you can use both, but sometimes just blasting them is actually more efficient and easier.
Remember there's this slide on my talk of yesterday in which I had get, and it called get impl with a 0 in a key position there, and then 0 essentially iterated the whole thing. So that was a poor man's way of keeping track of where you are in the list.
I think we need something dramatically simpler to access elements of a pack.
So we have another one. So ask anything. I mean, come on, man. Ask some questions that are going to get these guys arguing.
Yesterday I learned that I shouldn't use raw pointers. And raw pointers, I think, if I remember right, also references belong to that category because it's the same thing. Let's say if I have an object model of my application and a collection of documents in the application, and I want to return the nth document from a collection. What should be the type that I'm returning? Today I would use constref.
Yes, and I would continue to use constref. That was not in the list. If my definition of a raw pointer was a pointer with implied ownership, right? Which means that it's in the case of a reference, there's no implied ownership.
Yeah, you've been trying forever. Sorry, man.
Yeah. Similarly, I was saying you can use pointers to denote positions, but not for ownership.
Right.
Go for it.
So I was looking through the slides of the speakers from yesterday and today, and it seemed inconsistent whether you were going to use the member or non-member begin and end. Is that a stylistic choice, or are there guidelines that could be proposed for it?
Use the non-member one.
I have a slightly different convention. If you're directly calling something on a vector or something, use member. Why not? You get your autocomplete, whatever. The case where it matters is generic code. If you're templating something on container, absolutely use non-member, because the whole purpose of that is A, they work with built-in arrays, and B, they are extensible to things that are not arrays and they're not classes with .begin and .end, but somebody has then grafted these non-member functions on. It's just like how the range-based for loop works. So in generic code, definitely use them.
STL is mostly right, except he's not, because you should always use non-member begin and end. Even if you're using a vector today, you may change to my custom vector tomorrow who may not have member begin and end. Do not use member begin and end. Get out of the habit.
Yeah, but you'll be informed when your code fails to compile.
We can even correct it, Herb.
Actually,
Charles
we
wanted
should
to
have,
fight, so I'm trying to help.
Actually, we should have a language feature that made it unnecessary to have the distinction. In other words, when you say f of x, it first see if there's an x.f, and if it isn't, you get the global one. But don't hold your breath.
And part of that package would be extension methods.
Yes.
So Enrique, we're getting really low on time, so now it is answer as fast as you possibly can time. So go ahead.
Okay, I'll ask as fast as I possibly can then. I see a lot of new additions in C++ 11 around memory management and, managing your resources, shared pointer, weak pointer, unique pointer, things like that, which are all just freaking awesome. I love that. But I feel like in most of the large projects I work on, I tend to have to do a lot more work around memory management that seems to always fall on me and the guys building something ourselves. We need an arena allocator, or we'll do something for hot-cold splitting or something like that. Is there anything that you guys are thinking about in the standard library and the language to make that easier for us?
Yes.
Good answer.
If you want allocators, the library working group is your friend.
Allocator happy.
All right, so we got a guy right here.
Hi, I'd like to know what you're thinking about friend, and if there's any work to provide a sensible alternative.
So what?
I think you mean the keyword friend. And actually, it's funny. Once every 2 years, somebody asks me that question, and I have to remember what that is because I never touch that keyword. It's just not part of my world.
Yeah, exactly.
Yeah, I don't have any friends.
Yeah.
So, and as a follow-up for that, though, I think we're going to see a good solution for that in modules, which is rather than talking about friendship and befriending, instead we're going to talk about access control. And actually, fine-grained, precise access control, because control of access to interfaces is a real problem. But friends don't even provide that. They provide a limited amount of access that isn't fine-grained to a subset of the set of interfaces, and the wrong subset.
So I'm going to say I actually use friend, and I use friend a lot, but not for the reasons anybody thinks. I don't like to have my code separated, so I tend to put all of my code directly in my class definition, but I hate member functions. So I can put code into my class definition by inlining a friend function directly into my class definition, and that keeps everything in one place.
That's so clever.
And you're making the class a scope. I mean, think about what he just said.
Over there?
Two quick ones. We were just talking about non-member versus member begin and end. I mean, is it possible that you're going to get better overloading for const vectors in non-member begin and end to be able to return, a const iterator rather than having to worry about that whole complaint?
No.
And we just added cbegin, cend to C++ 14.
Yeah, but then I had to remember, I meant without having to remember to type, begin versus cbegin or, and all that kind of stuff, and have it always work. And the other part is, we just said, always use signed integer unless you have a specific reason for using unsigned. But all the ordinals in STL, vector size of and all that kind of stuff, they're all unsigned. And so it's...
They're wrong.
So they're going to get... it's going to pollute, right?
We're sorry.
As Scott would say, we were young.
Yes. We've already asked a few questions. Anyone who hasn't asked a question? Okay, I see somebody. The shy ones are coming up.
So I have a question for Chandler. I really enjoyed the talk, but some of the things that you were addressing seem to be in the category of, don't do that. So don't use new and delete. outside of scope. Use RAI. Also, don't do weird things in destructors, or don't do bad things in destructors.
Or just don't use inheritance.
So understand that when giving a presentation and a demo, I'm constrained by the format. I assure you that the bugs we find are bugs in real, well-thought-out code. That doesn't mean it's always pretty or good. Sometimes it's old. Sometimes people make mistakes. There are lots of reasons why these things happen. I wouldn't assume that the actual code that causes bugs looks like demo code on a slide.
I just want to make one comment. When you're trying to give people guidelines, if somebody says, don't do blah, 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 what they almost always really mean is, as a general rule, you shouldn't be doing this, and you probably should be doing this other thing instead. So they're trying to discourage you from doing something, and they're trying to usually implicitly suggest there's something else you could be doing to accomplish the same end, which would have more advantages and would have fewer disadvantages. But a shorthand way to say that in many cases is don't do blah, blah, blah. But there's virtually always some set of circumstances where you might need to do something. I mean, at the end of the day, somewhere in the STL, guess what? Somebody's calling new. They're calling it really indirectly through a member function called allocate, but really somebody is really calling new somewhere, and that's okay. But nevertheless, even the people who do that would say, no, you should never call new. But someone's got to do it somewhere. So don't do blah, blah, blah as a blanket condemnation, because that's not usually what it's intended to be.
And the only things where there is actually a blanket condemnation, you don't hear it from us, you hear it from your compiler with a warning.
And even in the STL, when we use like bare new, we've been burned. We new up a node in a map, and we start looking for where to insert it, and we're using the comparator to try to find the right node, and then the comparator throws an exception because that's allowed from user comparators. And we leak the node because we said raw new, and we didn't use a unique putter internally. So even your implementers get burned by this. So, yes.
The sanitizers found a large number of compiler bugs. A large number.
All right, so we're getting really low on time, but we're going to go late. We're going to have the bus leave a little bit later than it normally does. I know most of you obviously didn't take the bus, but those of you who did, we got to end then, and plus people have to go home on the production crew. And we have a party tonight. So yeah, let's get 2 more questions and we'll roll.
And remember to write code tonight. I know several of you have already written graphical applications, and email him.
I already got one, by the way, and the person did it in 2 hours. Is that you? Rock and roll, man.
So my question is regarding data layout of a class. A lot of times you like an array of data structures where you're only going to access one element of that data structure as you iterate. It would be more efficient if you had separate arrays of all the members of that structure. So I'm wondering, is there any way that we could have the compiler break apart data structures and access them more efficiently, as opposed to requiring the user to understand the performance implications of the memory layout?
So I'll actually give you 2 answers. One, yes, the compiler can do it. It's very hard. Chris Latner's PhD thesis actually touches on this and the data structure analysis he did. And essentially no one does it because it's too hard and it doesn't work enough. However, there's still hope. One of the primary use cases driving reflection is AOS to SOA. And building container types that can automatically do this transformation by reflecting on the structure and building a structure of arrays.
There was, I don't know if this was his work or not, but there was a paper actually in the GCC conference in 2005 which specifically talked about doing that and some early experience reports with it. It's very constrained due to the C++ object model, but if you're interested in it, that'd be a good place to start, I would think.
So we're winding down. There has to be a question we'd all want to hear each of these guys answer. Where's C++ going to be in 100 years? Come up with it, man. You have it?
That was the question of mine.
Where is C++ going to be in 100 years? Really? That's the one you would choose? All right. It's been chosen.
Well, for small values of 100.
So Herb, where's C++ going to be in 100 years, man?
Let me take a minute to share an anecdote that was really revealing to me. I was having lunch a few months ago with somewhere in the world with a language expert who's well known in his language, participates in the design. And he said something interesting, and the synopsis is that he has really thought about the future of C++ and thinks it has a bright future. And the reason he gave was this, is because many languages try to optimize for particular use cases. And they will automate things for you, do things on your behalf which involves hiding what's really going on, which gives them an advantage in the short term and for that domain. And some of them are even very general purpose languages, managed languages. But as technology moves, more and more there's an impedance mismatch and they have to adjust, and they have difficulty because they were hiding stuff from you, and the stuff they're hiding changes in material ways more and more, and they find that they run out of legs. And he said and it made a great impression on me, because he said out of the blue, one of the reasons he thinks that C++ has a bright future is because it doesn't hide anything from you. That is why it has managed to stay current. That is why it has managed to adapt to new kinds of environment and hardware that didn't exist in anybody's mind when Bjarne first put this together. And I think that's an insightful comment and very true. So I don't know where C++ is going to be in 100 years, but if it stays true to its principles, whatever hardware there is then, it will map well to that.
Excellent.
No? Come back to me.
Okay,
like
come
this,
back. So let's try to...
Looking at the history of programming languages, I don't think any language has ever survived for more than 50 or so years. But I believe Bjarne is going to say something about that. I don't know if C++ is going to be there or not. But I hope that it's going to be the basis of the birth of an even better language.
I think the oldest programming language currently is something like 58 years old. And so 100 years is a very long time, and very few of us will be around to see the answer. So I could predict anything.
All right.
But no, I think there'll be something that'll call C++, or a derivative of that name, and it will have two parts. It will have an abstraction part, which is much better and nicer than what we've got today, and it'll have a mapping to the hardware part, which will be much more efficient and capable than what we have today. The fundamental of C++ is exactly that, the mapping to the hardware and the abstraction mechanisms.
It's a very funny question to address, because I can't stop thinking my kid is going to watch this probably in 50 years, not 100. Hopefully 100,
So don't get it
who
wrong.
knows, with the technology and all. He's 4 now. So, dear Andrew, let's see. Daddy, well, here's the thing. In many ways, I hope what's going to be out there by the time this video is going to look completely ridiculous and obsolete, and they were wearing these pants, those and these shirts. Are those buttons? So in many ways, I hope I can't fathom what's going to be in only a few years, maybe 50 years or 2 decades. I hope in many ways I can't even imagine. And if I can, I'm worried that if it's within the bounds of my imagination, the future is going to be pretty bleak, because I don't have so much imagination. So in many ways, I hope I can't even think of what's going to happen. What I do believe is that there's always going to be a necessity for. Okay, let me put it this way in a really short sentence, because I know we're. C++ in 100 years or N years is going to be where the von Neumann architecture is going to be. If it's going to be thrown away, then C++ is going to be thrown away. It's going to thrive. It's going to continue being there. C++ is going to continue being there. I'm saying this because C++ is fundamental memory the memory model with pointers and addresses and what's there and stuff like that, and where things are going. You have addresses of functions and you have all these good things. I think this is inextricably linked to the memory realities of the von Neumann model, and as long as that's going to be around, C++ is going to be there to exploit it. Of course, there's going to be more and more layers of abstractions on top of it, new languages, new ways of looking at things, maybe a lot of concerns that today are are very important are not going to be there anymore, such as like minute efficiency concerns and things like that. But in short, I think as long as von Neumann with the model, the memory model that we know today, as long as that's going to be there, there's going to be a language that's going to map to it, and C++ is a language that does map very well to it.
Excellent. I think if the question was 20 years, I could answer it possibly. 100 years is such a vast span of time. The transistor isn't even 100 years old. But I agree that if computer architecture stays roughly the same, that the C machine model as extended by C++ will still be around. I think that actually C++'s view of destructors will still be around, because that seems like a timeless thing. I don't think garbage collection can ever solve it. So I don't think that will ever displace the destructor model. But I don't know if what we think of as C++, the language, as much as I love it, may be around in 100 years. We'll have amazing technology, Clang and things like that are just the beginning. Source-to-source transformations could take a 100 million line C++ code base and losslessly transform it into something that doesn't have any of the C quirks while retaining backwards compatibility. So would that still be C++? If it had the same philosophy but differed radically in not having the usual arithmetic conversions and having something that vaguely resembles templates? I don't know. It may just evolve into something that is derived from C++, but it's not a new language, and yet it's not the same language.
Obviously, if it survives that long, which I think, it'll have evolved into something that looks very much nicer, otherwise it'll die. And so we may eventually get the kind of nice syntax some of us are dreaming about.
Yes.
Should I still be teaching about it?
So I was going to say, when I switched my major in college from EE to CS, my dad told me that I was nuts because by the time I graduated, computers would be programming themselves and I wouldn't have a job. So maybe that'll happen, but my comment was going to be, in 100 years from now, we're probably going to be waiting for C++ 10x.
Nice. Chandler, go for it.
If the computers are programming themselves, in which language do they do it?
C++.
So my theory is that in 100 years, it is much more likely that programming and computers and software and programmers of software will be as foreign to us as people moving wires in a patch panel are to us as programmers, right? We don't think of that as programming. And I think that the difference will be more extreme than the difference we have looking back. And so I don't think that we would, I think it's unlikely that we would recognize a programming language in 100 years, that we, this group of people, could today recognize a programming language that's used in 100 years as a programming language at all. But I'm confident there will be a path of evolution from some programming language in use today to whatever is in use then. I kind of hope that C++ is on that path. Yeah. Otherwise, I've made a bad decision. But that's the thing about the most detail I would venture.
Yeah, I agree with that. Every language today has progeny in something fundamental.
Fortran has been around for 50 years. Was that the 58 you were thinking of?
It started in 56. You can do the subtraction.
And there is no end in sight. So although I don't think that things will change that radically, it's interesting how we've been focusing on the 100 number. Nobody knows what's going to happen in 100 years technologically. However, it does remind me of a quote, and I've forgotten the person to attribute it to, that people routinely overestimate what can be done in 2 years and underestimate what can be done in 10. When you say 100, a lot of the things you've heard about the answers for 100 years from now will likely apply in 10 or 20 because we always underestimate how much change there can be in 10 years while we overestimate what can be done in 2.
I just applied that one recursively.
Andre.
Let me paraphrase Bjarne here. Nobody knows what most programmers will be doing in 100 years.
Hey, thank you guys. So how about a hand for the speakers?